Assalamualaikum. Today the fifth lecture of DSP is about the fast Fourier transform. In the previous lecture we discussed the DFT discrete Fourier transform. Here the formula of the discrete Fourier transform is x of k is equals to summation of n is equals to 0 to n minus 1 into xn into e power minus j k 2 pi n over n, where n range from 0 to n minus 1 and k is also range from 0 to n minus 1. Here it is discussed into the sorted and the unsorted technique. The sorted technique applied to the binary search and the unsorted technique applies to the linear search. Whereas in binary search the worst case analysis is 0 of log base 2n, but on the other hand linear search it applies on the worst case analysis of 0 to n. In DFT, the addition will be n into n minus 1, but in multiplication n into n is equals to n square. Here is the example of FFT where the signal is xn. Xn is equals to 2, minus 4, 3, 1, minus 2, 0, 3 or 1. The formula of FFT is equals to x of k is equals to summation of n is equals to 0 to n minus 1 into xn into e power minus j 2 pi k n over n. As we are familiar with this circle, here the first quadrant is 0.707 plus 0.707j. In the second quadrant it will be minus 0.707 plus 0.707j, and in the third quadrant minus 0.707 minus 0.707j, but in fourth quadrant it will be 0.707 minus 0.707j. When we applied this formula on this signal, then we get the values of x of 0, x of 1, 2, 3, 4, 5, 6 and 7. X of 0 is equals to 4, but x of 1 is equals to 1.172 plus 2.282j. X of 2 is equals to minus 6 plus 6j. X of 3 is equal to 6.82 plus 2.82j. And x4 is equals to 8. So x4 is the maximum frequency at x is equals to 4. The maximum frequency is 8, but after the maximum frequency all the values are conjugate of the values that are deferred from maximum frequency, like 6.82 plus 2.82j, minus 6.82 minus 2.82j. This is the conjugate of this value, this is the conjugate of this value, and this is the conjugate of this value. So when n is equals to 8, in this case the addition will be 8 into 8 minus 1, that is equals to 56. But in case of multiplication it will be 8 into 8 is equals to 64. So we know that Wn into k is equals to e power minus j 2 pi k over n. As we know that the formula of xk is equal to summation of n is equal to 0 to n minus 1 into x of n into w of n up to kn. When we put w of n into n in this value, then we get is equals to 1, and when we put this value into this equation we get 1. When we put this value into this equation we get minus 1. As we know that x of k is equal to summation of n is equal to 0 to n minus 1 into x of n into w of n up to kn. When we will divide this equation into the two parts, like we will divide it in even or odd portions, then let n is equals to 2r. When we put n is equals to 2r in this equation, the equation will become x of k is equals to summation of r is equals to 0 up to n minus 2 1, and x of 2r, here this is the even equation. Let's suppose this is a, and a is multiplied with the w of n up to 2rk, but in case of odd equation it will be summation of r is equals to 0 to n divided by 2 minus 1 multiplication of 2r plus 1. Here this is equals to a or even equation, and this will be equal to odd function. So the equation will become x of k is equals to even plus w of n up to k into odd. So when we take it equals to the A even, and when we take odd will be equals to the B, so the equation will become x of k is equals to A plus W n up to k is equals to B. Here this is the signal and we will calculate it according to the even or odd portions. So consider it these values are even values and these are the odd values, and we will divide it into the even 4-point DFT and the odd 4-point DFT. So these are the even values and these are the odd values. When we will put these values into this equation, this formula, we will get at x is x0, x1, x2, x3. So the values become 6, 4, minus 6 and 4. Similarly, when we put these values of odd 4-point DFT into this formula, the equation will become minus 2, minus 4, minus 6 and minus 4. So this is the formula of even and odd portions, like x of k is equals to A of k plus W n up to k into B of k. These are the even 4-point DFT which is equals to AK, and these are the BK, that is odd 4-point DFT. So this is W8 up to 0, W81, W82, W83. Similarly, odd 4-point DFT is W84, W85, W86 and W87. When these all AK put into this equation and these all BK put into this equation, we will get the final equation that will be equal to x of k is equals to AK plus Wn up to k into BK. So now in this case, when we will divide the equation into even or odd portions, the addition will be 4 into 4 minus 1, that is equals to 12 into 2, because we will 2 in this case here pretend the even or odd portions, and the addition will be equals to 32 and the multiplication will be equals to 40. Now if we compare this addition or multiplication terms with the previous one, so here we will analyze that 32 is less than 56 and 40 is less than 64, because in this case the addition and the multiplication will reduce from the previous one. But if we further divided our samples into the two points, means the 2-point DFT even or the 2-point DFT odd. So these are the values. When we put these values into the DFT formula, we get the 0, 4, 6 and 0. And when we put these values into the even or odd equation, it will become 6, 4, minus 6 and 4. Now the total number of additions is equal to 24 and the total multiplication is equal to 16. And this is the worst case analysis in which O of n log base 2 into n. If we see that the maximum frequency of the audio signal is 4K, but it has samples of 8K. In case of voice, the maximum frequency is 20K, but the number of samples are 40K. In 1 minute, when we have the 8K samples and multiply it to the 60, we will have 480K samples. But in case of 10 minutes, we have 4.8 million samples. It is important that the frequency resolution will be greater if the number of samples are greater, and it will be less if the number of samples are less. So this is all about today's lecture. Thanks for watching. Allah Hafiz.